Now, we said that we will calculate the reverberation time, okay, at 60 dB down. So, you know that at 60 that psi 0 and then net down to 60 dB down means psi 0 has to be down by 10 to the power minus 6 time. So, that way we calculate at 60 is equal to that part. Now, I said that suppose in a room at this point there is there is a source in here. So, at this point there may be reflection passing this time, this direction, this direction, this direction and this direction, all the direction the reflection is passing. So, there is a total number of reflection path, there is a different reflection length path. Now, can I calculate the mean free path, mean reflection path, mean reflection path? What should be this expression? Okay. Now, suppose that within there is a n reflection. Let us suppose there is a sound enclosure. I produce a sound and that create n reflection that can create that can go this way, that can go this way, then this way. So, n number of reflection is possible. So, single ray has an n number of reflection from different angle, different wall and different angle. So, every time the ray strike the wall, it will be absorption coefficient is A. So, it will be 1 by A will be reflected. So, if it is n time it is fall on the wall, so it will be to the power n time. So, you have understand, let us P is incident in the wall first time. So, what is the reflected power? P into 1 minus A, that is reflected, that is incident in the another wall. So, it will be P into 1 minus A into 1 minus A, then it is reflected in another wall. So, that n time reflection is possible, let us n time it is reflected. So, this is 1 minus A n time. So, it is nothing but a P into 1 minus A to the power n. Okay. So, after n time reflection, let us what is P square T? Let us after n time reflection, it is P square T is nothing but a P 0 which is initial power square minus 1 by A to the power n. Power also same intensity will be absorbed by A time 1 by 1 minus A. Okay. Now, if it is that, then what is this? This can be represented as a P 0 square into e to the power n into ln 1 minus A. So, absorptivity is A, 1 minus A I can say, ln n into ln of 1 minus A. A is I take the absorptivity, you can say the average absorptivity is A bar. So, A bar and A is let us say A. Okay. So, I can say e to the power same A to the power n can be A to the power n into ln 1 minus. So, e to the power n into ln 1 minus ln into A. So, in that formula I use that, because e to the power n into ln 1 minus A is nothing but A 1 minus A to the power n. I represent like this. So, let us the total path traveled by that ray is nothing but a summation of L j. J is the number of time it is. So, it is nothing but a C into T. It is nothing but a n into let us L mean. L mean is the let us average reflection path is L mean. So, if it is n time reflected, so n into L mean. So, let us L mean is defined as L m. So, it is nothing but a n into L m, which is nothing but a C into T, total time taken to reflected into multiply by the C. Okay. Now, let us L mean. So, n is nothing but a C into T divided by L m. I put the value in there. So, it is nothing but a p square t is nothing but a p 0 square e to the power n is nothing but a c into tilde by lm into ln 1 minus a, t into ln 1 minus a. Okay. So, what is RT60? RT60 reverberation time. Reverberation time is said that it is nothing but a 0.161 V by A, which said that the time required to decay the pressure 60 dB when the source is off. So, I can say at T equal to RT60, the P square T is nothing but a P 0 square into 10 to the power minus 6 dB down, 10 to the power minus 6 time down. If it is P 0 is the initial, rho c, here will be rho c and here will be rho c. So, rho c I am not consider. So, P 0 square into 10 to the power minus 6. Okay. So, it is nothing but a P 0 square 10 to the power minus 6 is equal to, what is there? P 0 square e to the power c by lm into 1 minus a into t is nothing but a RT60. RT60. So, P 0 is cancelled, 10 to the power minus 6 is equal to c e to the power c by lm 1 minus a into RT60. Okay. Now, I do that. So, I take the ln both side. So, it is 6 minus 6 ln 10 is equal to c by ln c by ln ln 1 minus a into RT60. Okay. So, I can calculate this this value. Lm is nothing but a c by minus, this will be minus, and 6 10 ln 10 is nothing but a 13.8 into ln 1 minus a RT60, which is equal to, almost equal to c by 13.8 into a RT60. Okay. What is RT60? I can say c by 13.8 into a into 0.161 V by a. So, what is a? Again I can write this is equal to c by 13.8 into a into 0.161 V by s into a. So, a and a cancel. So, it is nothing but a c by 13.8 into 0.161 V by s, which will equal to 4 V by s, if c is equal to 343 meter per second. 4 V by s. So, Lm mean free path, MFP, Lm mean free path is equal to 4 V by s, 4 V by s. Is clear or not? Is clear? Now, if I say number of reflection, let us I say how many mean free path is 4 V by s. So, if I say how many reflection will be present during in 1 second, number of reflection per second n. So, number of reflection per second, number is mean free path means average path. So, it is nothing but a c by MFP. So, c by 4 V by s. So, c into s by 4 V. V is the volume of the room, c is the velocity of the light, S is the surface area of the room, number of reflection. So, depending on the number of reflection, I can say whether this room is supports statistical reverberation time or not. So, for a given room dimension, I can calculate mean free path, I can calculate number of reflection per second, and if I say number of reflection is per second is this, then the number of reflection in the reverberation time C into S by 4B into RT60, number of reflection within the reverberation time. So, I can calculate all those parameters. Okay. So, this is the more or less reverberant time. There is an example I have given here. Let us V is given, an auditorium has a volume is this, S is there, average absorptivity is given. Calculate MFP and RPS, reflection per second and RT60. So, first one is MFP. What is V? V is equal to 1500. So, it is 5 into 10 to the power, I can say 3 to 5 feet cube. It is feet, let us meter cube, and S is equal to 42 into 10 to the power 3 meter square, and A is equal to 0.128. Okay. So, V is given, S is given, A is given. What is MFP? It is nothing but a 4 V by S. So, 4 into 5 into 10 to the power 5 divided by S. S is nothing but a 42 into 10 to the power 3. So, I can calculate it, number of reflection. Then what is RPS, reflection per second? It is nothing but a SC, sound velocity, divided by 4V. So, what is S I know, C I know, V I know, I can calculate. RT60 is nothing but, since I change it to meter, so it is nothing but a 0.161 divided by A into V. I know V, I know A. What is A? A is nothing but a S into A. So, for a given, now I come a practical example. Suppose I have an auditorium, what will be given when you design an auditorium? Let us say that I want to design an auditorium for some purpose. So, from the purpose, I know the reverberation time range. I have to design an auditorium for reverberation time 1.2 second to 2 second. So, RT60 is given. RT60 is given. Reverberation time is given 1.25 to 2 seconds. Within this range, my RT60 should be. Now, if I said within this range, my RT60 should be, then what is given? Civil drawing is given. So, the volume I know, surface area I know, different surface area I know. There is a wall, there is a door, there is a window, there is a stage, there is a all floor, there is a chair, everything absorptivity is given and their surface area is given. Then I can say A I can calculate, capital A I can calculate, average total absorptivity of the whole surface area. Once I know A, I know V and RT60, I can estimate what kind of A I required. So, it is RT60 is nothing but a 0.161 V by A. So, A is nothing but a 0.161 V by A. Let us I put 1.25 2 second, then I calculate what kind of range of A I required. Then I know surface area and absorptivity and calculate that A from that angle, design angle, where I put a acoustic cloth, where I put a gypsum board. So, I know the absorption coefficient, based on that I calculate the A. So, if A is matched with this A, then I can say my reverberation will be close to 1.2 second. So, that way I can design. So, I will discuss what kind of treatment is made in which area, why it is done, that we will discuss in design the studio. So, more or less you have an idea about reverberation time, then mean free path, then number of reflection in second. So, those kind of information now we have. So, we can calculate those things for a given. So, there is another one slide where I have taken from the internet it is. Again there is a different kind of reverberation time, you can read it from that PDF file which will be supplied to you, that different kind of different purpose and their reverberation time range is given. If it is a cinema, then the reverberation time 0.8 to 1.2 second. If it is a small theatre, it is 1.2, 1.4. If it is a multipurpose auditorium, reverberation time 1.4 to 1.8. So, there is a different reverberation time for different purpose which is used or which is standardized by the architecture form is there, or it is standardized by the world, you can say that there is that is readily available. So, if I want to design a classroom, then I require a RT60 from 0.6 to 0.8. So, within that range I can design my classroom. So, what that RT60 define, once that civil drawing is given and RT60 range is given, then my what kind of acoustic treatment is required is can be designed from that parameter. Okay. So, let us stop here. Next lecture I talk about the small room acoustics, what is small room acoustics and large room acoustics. Okay. Thank you.